Hi all, in this lab, let us understand how to do the private link integration between the REST API of the API gateway and a VPC resources. Okay, for example, in this case, we are running a Nginx web server on EC2 machines, and these EC2 machines are running behind a load balancer, which is an internal network load balancer. Okay, now let's get started to see how the architecture looks like. Okay, so we have one REST API called Private Integration API. It's of type regional, and we have defined one resource internal hyphen NLB, and there is only one method called get. Okay, and we create a VPC link private link resource, okay, which is part of the API gateway, and then this is connected to the internal uh, network load balancer. Okay, this internal network load balancer is part of the customer account, and the EC2 machines are running Nginx web server, and these are running in a auto scaling group, and they are part of the target group which is behind the load balancer. Okay, now when a client sends a request, so in this case it's an empty request because it's a get request, and the same request goes to the target, which is the backend EC2 machine, without any change. Now the Nginx will respond a web page, okay, and that page is coming back to the client. Okay, so in this case, what we're trying to do is how to integrate any private resources which are running in the customer VPC account. Okay, these could be running on ECS task or EKS pods or any other servers, EC2 servers for that matter, right? So any privately hosted resources can be connected to the API gateway, and clients can access these resources, okay, through via REST APIs. Now let us go to the source code to see how to implement this. Hi all, in this lab let us understand how to create a VPC link integration with API gateway. Okay, now if the backend is in a private VPC and you want the clients to connect to those resources and services in the private VPC via API gateway, so you can use a VPC link feature, that is a private integration with VPC resources. Okay, let's get started. Okay, now let's first look at the API gateway definition. Okay, so here we are creating one REST API called Private Link Integration API. Okay, the type of the API is regional, and the definition for this API is coming from OpenAI spec. Okay, so this is in this file. Now let us go to this file and see how the definition looks like. So in the Open API, we are creating one resource called internal-NLB, and there is one method called get, and the integration type is, if you look at HTTP proxy. Okay, the connection type is VPC link. The type is HTTP proxy. So that means we are using a HTTP proxy integration for the VPC link connection. Okay, so here we have to provide the connection ID, the VPC link ID that we have to create, and the method is get, and the URI, this is the internal load balancer DNS name that we are connecting for the backend services. Okay, and the default response is 200. Okay, so this is pretty straightforward. The only thing we need to keep in mind is the connection ID and the URI and that integration type VPC link. Okay, now let us go ahead with the rest of the configuration for the API REST API. Okay, now here I am creating one resource called VPC link. The name of the VPC link is this REST API API link internal NLB, and the target ARN is coming from a load balancer. So module.nlb.arn, which we will look into that in a short while. Okay. Now the API gateway, the REST API methods also like this. These are the default configuration. I am also creating a dev stage and creating the deployment. Okay, and there are some IAM roles which API gateway assumes to make any calls to the backend AWS services. Okay, now going back to the NLB configuration, so here we have this module, Terraform module, which is ALB. So though it is the name says ALB, we can use to create ALB or NLBs. Okay, so here the load balancer type is network. The name is this API gateway NLB internal. It's an internal load balancer because we are using a private connection. I mean private integration between the API gateway and the NLB. So it has to be internal NLB, and the VPC ID we have to provide. So the VPC ID is coming from another module that we will see in a while, and the subnet IDs. So the private subnets where we want the load balancer to be created, and we can also create security group rules, ingress rule. Okay, so from 4 to 80 to 84, TCP traffic coming from all this, from for all the traffic. So this is like a public traffic. Now UDP traffic also I'm enabling, though we don't have the UDP connection here. I'm just enabling it, and the egress is all protocol, and in this particular CIDR block. Okay, the VP CIDR block. Now the listener, there is one listener port EIT and a TCP protocol, and we are forwarding that to a target group called EC2. Okay. So the target group configuration, if you see, the protocol is TCP, port is EIT, target type is instance because we are registering few instances. Okay, EC2 instances. Now, now coming back to the EC2 configuration, this is a data resource which provides the AMI for Amazon Linux 2. Okay, for x86 architecture. Now I'm creating a launch template with this image ID, instant type T3 medium and EBS optimized true. The VP security group also I'm creating it. We'll see that in a minute. And some tags. The instant profile also I'm creating it because if you want to connect to this EC2 instance via SSM, and we need to provide the SSM IAM permissions, right? The user data section is where we are installing the Nginx. So for example, if I go back to this file, Lab17 EC2 user data. So you will see that the steps to install Nginx server. So I'm installing a simple HTTPD server using a yum and writing a simple message hello world from this host name. Okay, so this is very straightforward. Now coming back to the EC2 configuration. So this is the launch template I'm creating it, and then this is the security group. Okay, so I'm creating the security group in this VPC, and I'm allowing the port 80 TCP protocol from this header block of the VPC, and outgoing connections are all traffic. And I'm also allowing the traffic from the network load balancer. Network load balancer also is having security group. This feature was launched some time back, so you can attach security groups to network load balancer as well. Now, I'm using another module, which is autoscaling module in Terraform to create autoscaling group. Okay, so this is name of the autoscaling group, and these are the subnets, and the minimum 1, maximum 2, and desired 2 instances. I'm using the launch template. So I don't want to create a new launch template. I'm already created. So I'm using that, and that is ID, and using the latest version of the launch template. So as and when you make some changes to the launch template versions, you can use that latest one. Okay, and this is where I'm registering the instances to a target group. Okay, so this is a module dot nlb dot target group ec2. So within this nlb there is one target group with index ec2, so I'm registering all the instances from this ec2 autoscaling group to the target group. Okay, now this instance profile which I'm creating for SM access. So this is the role, IAM role, and the IAM role is assumed by the EC2 service. Okay, and this is a managed instance policy. I'm attaching it. Amazon SM managed instance core. Okay, so this is the typical configuration that you use if you want to provide a instance profile. Okay. Now coming back to the VPC configuration, so I'm using a VPC module in the Terraform registry to create various public, private, and database subnets. So, and the configuration to create this is in the vars file. So, if you see, I'm creating two subnets, across two ASIs, private subnets, public subnets. So, this is a header block, and I'm also attaching the secondary header block. So, though we are not using this, but this is just a sample VPC configuration. Now, let us go ahead and deploy this stack to see how it works. So Terraform init, I've already done that, so it should be faster. Terraform plan. Okay, now Terraform apply with auto approve. So this is done. So we see that the VPC is created and the REST API is created, the VPC link is created, and the NLB is created, and EC2 auto scaling group is created. All of the resources are created. Now let's go to the console and see how this looks like. Okay. So first let us see the API gateway configuration. Okay. So within the API gateway, we have defined one API. It's of type REST. Okay. If you see, it's a REST API and regional is the endpoint. So within that we have one resource slash internal NLP and one method get. Okay. So if you see the authorization, request validator, all of them are default. So there is nothing much here. Now integration request, this is where we are configuring the integration type to be VPC link. Okay. Now this is endpoint. This is the NLB DNS name. Okay. Now, if I go to the edit option here, you see method is get VPC link. This is a VPC link ID and this endpoint URL for the NLB. Okay. Integration response, since it's a proxy integration, we don't have any option to make changes here, and this is also default. Okay. Now, before we go ahead and test it, let's first look at the other resources. So if I go to the VPC links, so this is my VPC link I've created, and this VPC link is only for the REST API. Okay. Now this is a target link. Okay. And this is the ID. This ID is required when you configure the Open API specification. We saw that. Now let me open this link. Okay. And this will take us to a network load balancer. Okay. So this is the network load balancer. Type is internal, and there is one listener port EIT, and it is attached to one target group. Okay, let's go there. So the instance type is the target type is instance, protocol is port EIT TCP protocol, and there are two target instances which are in the healthy condition, and these are the EC2 instances. Okay, both of them are healthy and running at port EIT. Okay, now just to see where these EC2 instances are created, let us go to the auto scaling group. Okay, and we have one auto scaling group and which is using a launch template. So this is what we have created in Terraform, right? So the launch template is having the AMI ID, the T3 medium instance security group, right? And if you go to the advanced configuration, we also see that now let's go to the latest version. Uh, so here we have also configured instance profile. Okay, and this is where the user data section is configured, and here we are installing HTTP server and just writing a hello world message to the users. Okay, now if I go back to the auto scaling group, and you see there are two subnets configured, and this is a load balancer target group where we are registering these instances. Okay, and so this is how. So in the auto scaling group, we are configuring the target group, and this is where the instances are getting registered. So if you look at the instance management tab, there are two EC2 instances which are healthy and running, and these are actually a private instances. Basically, they are using the private IP within this VPC. And if you go to the security group also, you can see we are allowing the traffic from only the private IPs within the VPC and also from the network load balancer security group. Okay, so this is how the things are configured. Now let's go ahead and test the API. Okay, now if I go to the API, so if I go to the get and go to the test tab and simply do a test. Okay, now you see the HTTP response is 200 and hello world from this instance name. And if you see, we are basically making a call. So at this path slash internal NLB, and most of the parameters are default, and it is making a request to this network load balancer. Then request headers, request body. So we are not passing anything. and request is sent to this. Okay, status is 200, and the response from the endpoint, okay, is hello world, and that's what we are basically seeing in the output. Okay, so the endpoint response body before transformation, after transformation is same. So since it's a VPC link, we cannot make any changes to the response, so the same thing is coming back. Now let us go ahead and test this in CLI. Okay, so if I go here and get the URL of the API, so this is the URL API, and I can simply make a curl API, okay, to make a call to the API gateway, and which internally talks to the NLB and the EC2 instances, and the response is coming. Okay, so what we have demonstrated so far is basically a private link, demo between the API gateway and any VPC resources. It could be EC2, or it could be containers running in ECS or EKS. It could be any of that use case. Okay, so this is how we can implement the private link connection.